where was I? Yeah. Okay, so from the pulmonary veins, the blood is going to pool into the left atrium, okay? Left atrium, because the left side of the heart is going to deal with pumping blood to the entire body. That's why it has a larger that's why the cavities are larger. That's why the muscles surrounding them are larger, because it has to provide the force to get blood all the way to your fingertips and your tippy toes. It's really far away from the heart, okay? So it's going to pool into the left atrium up here. The atria are going to contract, pushing the blood down through, it's actually easier to see it from this point of view, down through this valve. Does everyone see this valve right here? So from the left atrium through this valve called the bicuspid valve or the mitral valve. What are the points, what's the function of having valves in the heart?
Keep it going in one direction.
One direction. Unidirectional flow of blood to prevent backflow. So the valve that separates the left atria from the left ventricle is called the bicuspid or mitral valve. These strings that anchor the valve down, these are called chordae tendineae. So if someone says, you know, when someone says you're tugging on my heartstrings, you actually have heartstrings. Now you can say you're tugging on my chordae tendineae and sound really pretentious, okay? So here's our chordae tendineae. Function is to help anchor the valves down. And they're anchored at this spot right here where they're anchored into the wall. That's called the papillary muscle, okay? So where they're anchored into the wall is called the papillary muscle. So the blood is now going to pool into the left ventricle. Okay? The ventricles are going to contract, and it's going to push the blood up and out through the aortic semilunar valve. So it's going to push the blood up and out through the aortic semilunar valve, through the aorta, where the probe is coming out of. Okay? So here's the aorta. You can't see the aortic semilunar valve on the heart, on the cow heart, but you can see it on the models. So through the aorta to the arteries, and then arterioles, and to the capillaries. What happens at the capillary beds?
Gas exchange.
Gas exchange. Where does oxygen go?
Into the tissues.
Into the tissues. Why?
To make ATP.
So the tissues can use it for cellular respiration to make ATP. Those tissues have already been making lots of ATP through cellular respiration, so that means the tissues have very little oxygen, and oxygen is going to want to go from the blood to the tissues because of a concentration gradient. What do the tissues have a whole lot of? A waste product that has been built up.
Carbon dioxide.
Carbon dioxide. And because there's a concentration gradient there, carbon dioxide is going to diffuse from the tissues to the blood, right? So now our blood is oxygen poor and CO2 rich. So now we have deoxygenated blood, rich in CO2. What do we have to do with it?
Bring it back to the heart.
Bring it back to the what?
Lungs.
The lungs, eventually, because well, what do we need to do? We need to dump off that CO2 and get more oxygen. But the blood is really sluggish and doesn't have a whole lot of pressure because it had to travel all the way to our fingertips and our tippy toes. So it doesn't really have a whole lot of pressure behind it to reach the lungs. And then also get back to the heart. So where does it have to go first? To the heart, so that the heart can pump it to the lungs and give it a little bit more of a boost, right? So from the capillaries, the deoxygenated blood is going to travel through venules, and then through veins, and then back to the heart, okay? If we're dealing with deoxygenated blood from below the heart, it's going to come in through the inferior vena cava, which is right here, okay? Inferior vena cava. If we're dealing with deoxygenated blood from above the heart, it's going to enter through the superior vena cava, okay? These structures are on the back of the heart. So inferior vena cava, deoxygenated blood from below the heart. Superior vena cava, deoxygenated blood from above the heart. What about the heart itself? The heart has to have blood supply, right? Well, we're going to have deoxygenated blood from the heart itself, and it's going to pool into this structure right here that I'm pulsing called the coronary sinus. Okay, so if we're dealing with deoxygenated blood from the heart itself, it's going to pool in the coronary sinus. And look, my fingers are touching. That means these structures are all connected. Okay, so all of this deoxygenated blood is then going to pool into the right atrium, which on this heart, actually if I switch it over, okay, here's the right side, and I know this is the right side because it's much smaller. This is the ventricle because it's coming to a point, to a V. The atria, does everyone see that valve all the way up into the right side of the heart? Does everyone see that valve? sandwiched all the way up there? Everyone see it? Yes? Okay, that's the tricuspid valve that separates the right atrium from the right ventricle. We just can't see the right atrium on this heart because of the way it's cut, but it's up there above that valve, okay? So this valve, in separating the right atrium from the right ventricle, that's called the tricuspid valve, okay? The atria are going to contract. It's going to push the deoxygenated blood through that tricuspid valve into the what? The right ventricle. The right ventricle is going to contract, and it's going to push blood up and out through the pulmonary semilunar valve, which is, this one's a little bit harder to, okay, so, which you can't see the pulmonary semilunar valve on this heart, but you can see it on the models. But up and out through the pulmonary semilunar valve, let me get it, it's going to come. It's trying to come out. Does everyone see? Mm-hmm. Okay, there we go. See? Through the pulmonary semilunar valve, through the pulmonary trunk. Okay? So this structure right here is a pulmonary trunk. Would it be an artery or a vein?
If it's going away from the heart, it's an artery.
It's an artery, but is it carrying oxygenated or deoxygenated blood? Deoxygenated, because it's coming from the right ventricle, right? It's coming from the right ventricle, so it's deoxygenated, but it's an artery. That's why you can't say arteries always have oxygenated. You just say arteries carry blood away from the heart, veins carry blood to the heart. Okay? So from the pulmonary trunk, where is that going to direct blood to? Where is it going? The lungs, pulmonary trunk. What happens at the lungs once it gets there?
It gets oxygenated.
It dumps off CO2 and gets more oxygenated. Where do we have to carry that oxygenated blood?
Back to the heart.
Back to the heart through the
Pulmonary vein.
through the pulmonary veins into the left atrium. And then so we just made full circle. Okay? Does that make sense? So those are all the structures that you have to be able to identify on this heart. If it's listed on the document, though, and I didn't go over it here, you should be able to identify it on the models. Okay? All right? That's the heart.